So now, armed with the knowledge of what an exponent is, what we're interested in is their superpowers, pun very much intended. We want to see how powers relate to one another, and later on, we'll begin to look at some very interesting consequences of our definition for an exponent. But that's some fun that we'll have later on. As a start, we just want to figure out some basic relationships that powers have with one another. And the first relationship we look at is, what happens when I multiply powers that have the same base. So for example, if I've got something like 2 to the power of 2 times 2 to the power of 4, one way that you could work out the value of this expression is you could evaluate each of these guys, right? So you could work out 2 to the power of 2 is 2 times 2, which is 4. 2 to the power of 4 is 2 times 2 times 2 times 2, which is 16. And so if you times them together, you should get 64. But obviously, if I then make these exponents large, that becomes a bit of a mission to work out, right? If this was 2 to the power of 100, then you'd have to work out what 2 times 2 times 2 times 2 times 2, 100 2's multiplied together would be. And that would be some absurdly huge number. So we want to kind of find a relationship that we can apply to any power. And not have to worry about these heavy kinds of computations. So let's look at what happens when we think about what this expression means. So 2 to the power of 2, as we said, so maybe let's just do that in one color. So 2 to the power of 2 is the same as 2 times 2, and we're timesing that with 2 to the power of 4, which is 2 times 2 times 2 times 2. And so the answer to that is 2 to the power of 6, right? There are six 2's that I am multiplying together. So that would be 2 to the power of 6. Now let's see if we can use this idea for powers that are quite big. So for example, say we had to figure out what is the value of this product. And so, you really don't want to be sitting and multiplying 58 3's together. 3 times 3 times 3 times 3 times 3 times 3. And then once you're done with that, multiply that result with another 75 3's. You don't want to go that route, okay? Let's use the same concept that we used in the previous example. What this product means is I'm multiplying 58 3's together, and then with another 75 of them, and then with another 22 of them. So I'm saying 3 times 3 times 3 times 3 times 3 times 3 times 3, 58 of them times 3 times 3 times 3 times 3 times 3 times 3, 75 of them times 3 times 3 times 3 times 22 of them. So in total, I'm multiplying 58 plus 75 plus 22 3's together, and that adds up to 155 3's that are multiplying together. So the result of this product is 3 to the power of 155. And so in general, a to the power of m times a to the power of n will be equal to a to the power of m plus n. So if I raise some number to the power of m, so I'm multiplying that number by itself, m of that number by itself, and I multiply it by another n of that number, then all in all, I'm multiplying m plus n of that number. So an example of applying this, x to the 5 times y to the 3 times x times y to the 8, well, how many x's am I multiplying here? I'm multiplying 6 of them, right? Because there are these 5 over here and another one over there. And you can also just imagine that there's that invisible exponent of 1 over here. So 5 plus 1 gives me 6. And how many y's am I multiplying? Well, there's 3 of them here and then another 8 over there. So in total, I'm multiplying 11 y's.